For today's lecture, we're going to go over another structural design pattern called the facade. The facade is a structural design pattern that provides a unified interface to a set of interfaces in a subsystem. It defines a higher level interface that makes the subsystem easier to use. So in order for us to get a better understanding of what the facade is, I think we should go ahead and look at the definition of a facade. So I'll go ahead and pull up the definition right here and say facade. Expand this. All right, so if we go here and look at this left section, we'll see that the facade is generally the front part or exterior of a building. All right, the front part or exterior of a building. So if we look at this image here, we see exactly that, the front part or exterior of the building. All right, we're not looking at the other parts of what's internally used to build this building, right? Like the plumbing, the electrical system, or any of that internal stuff. All we see is the front part or exterior of the building. And essentially that is what the facade pattern is. The facade pattern is a simplified interface provided to us, the user or the client, to use and hides other complexities involved for getting us to get something to work. For example, let's take the example of a remote control. When you have a TV remote control, you press the on button and it turns on, right? I mean, obviously, internally, underneath the hood, there are tasks or events that are going on to make this TV turn on, right? But us, the user, we have a simple task of just pressing the on button. Or let's take another example of a party. We as a client might decide we want to have a party, a birthday party, for example, but we don't want to set up the birthday party. So instead, we go ahead and hire a party organizer that will deal with all that complexity, all that other stuff involved with setting up a party. Us, we go directly to the party organizer and that's it. So we just interact directly with the party organizer, and that party organizer will deal with that, all the other complexity that will eventually get the party going. All right, but that would give you an idea of what the facade pattern is. And for our example that I will demonstrate today, in our conceptual understanding of the facade pattern, is we will go ahead and look at how the example of a computer. All right, we all have a computer in which we have turned on the on button, and there is this booting up of your laptop, and that button is going through so many processes in the background that we are unaware of. All we as the user have to do is simply press that on button, and the complexity is hidden away from us. So that is exactly what a facade is. The facade pattern is dealing with. So let's go ahead and complete this here. What I have here are my notes on the right. So one of the pros or benefits of using this pattern is it avoids tight coupling between clients and subsystems. A use case to consider this pattern is when you want to provide a simple interface to a complex subsystem. So again, we want to provide a simple interface. So in our example, we're using the laptop on button that us as the user, we press it and all the complex tasks are hidden away from us. That's happening in the background. So let's go ahead and look at this diagram here where we have this client that is interacting or making use of a facade. And the facade provides to us a simple interface. So for us, we'll be given as a client a method called start laptop. And you can equate this to the button on a laptop in which we press, and it deals with everything that's involved with turning on the laptop. All right, so us as a client, this is all we see. This is all we need to use. And by using this here, what'll happen is in the background, all these other tasks within a subsystem will occur. So when turning on a laptop, there is power that's going to be supplied to different parts of the laptop, right? So there's that one task. There's a CPU that needs to start up. There's memory that needs to load up. And obviously there's many more other processes involved with turning on or with the turning on of your computer. But to simplify this example, right, I'm just using 3 processes just to simplify the example of what the facade pattern is. Okay, and if we look here, we also see that the laptop facade, if we look at this UML arrow here, it is saying that that the facade is composed of a memory, it is composed of CPU, and it's composed of power. So when we say compose, we're essentially saying that composition is involved. And if you know anything about composition, we know that composition has it has a relationship of has a. So so in this case, we're saying that laptop has power. A laptop has a CPU. A laptop has memory, right? So it creates has a relationship. And if we look here, we have a reference, we're using composition to store an instance of each of these individual subsystem components of power, CPU, and memory. And it's being stored here in the facade. And by storing it, making use of composition, we are allowing the facade to have access to all these other subsystem components. Okay. All right. So let's go ahead. Enough chit chat. So let's go ahead and start with this diagram here. So what I'll do is I'll go ahead and move my way from right to left over here for each of these individual subsystem components. So we'll go ahead with the class, and for the power we have a method called supply. All right, so supply is simply going to return, is going to have a console log of supplying, or just let's say power being supplied. All right, next let's go to our other subsystem component, which is CPU. And this one has a method of start. So here we'll have console log, and we'll say CPU starting. All right, for our final component in this subsystem, we have the memory with a method of load. And this one will console log, say memory loading. All right. So here we have a simple console logging of each individual subsystem component to provide us a conceptual understanding of this pattern. All right, so now that we have our subsystem components, next let's go ahead and create our facade. So I'll go ahead here and say the facade. And let me go ahead and note something here as well, and I'll just say subsystem components. All right, so let's go ahead and draw out our facade. So this is going to be, we're going to call it laptop facade. And again, because we're going to be making use of composition, so that way we can have access to our subsystem components. So that means we're going to have to store reference to each individual component here. So I'll start off with power. Next, we'll do CPU. And the last one is for the memory. All right, next we're going to go ahead and create a constructor. So this constructor is going to initialize our subsystem components and store them in each individual instance variable within our facade. So we'll say this.power is going to be equal to new power. Then this.cpu is going to be equal to new CPU. And then for the last one, we're going to initialize the memory. So we'll say new memory and store that in the variable or the instance variable of memory. Okay, all right, so at this point, when we create an instance of the facade, this constructor automatically runs and creates these subsystem components for us and stores them in their appropriate instance variable here. All right, so next we have a method within our facade called start laptop. So we'll go ahead and say start laptop. All right, and now for our start laptop, essentially what happens here is where we are essentially running through a set of tasks or sequences to execute the subcomponents that we want to, or to execute tasks that we want to run. Okay, so what we do here is I can go ahead and essentially, like as if we're going through a set of steps, we can say step 1. So for step 1, when we're starting a laptop, what do we want to do? Say, okay, we want to start off by supplying power to all the individual to components within our laptop. Okay, all right, so what we do here is we can say, okay, this dot power and then supply. Okay, so that's step 1. So now for step 2, we can go ahead and say, okay, well, after the power supplied, next I want to start up the CPU. So we would go this.cpu.start. All right, so do you see the pattern that's going on here? Essentially, this method is giving us, it's providing us a simplified way, giving the client or the user a simplified way to execute all these methods or these tasks that will be delegated to other subsystem components. All right, so we have this power which is being delegated to this power class here, and then we have this CPU here which is being delegated to this CPU class here. And then the third step here, and the final step for our example, is for the memory. So we can go here, this dot memory dot load. So we want to load up the memory. All right, so now we have 3 steps, and again, all of this start laptop is essentially delegating these tasks to the appropriate subsystem component here. Okay, so that's that. So at this point, we can go and try. We as a client can go ahead and make use of the facade now. So let's go ahead and say client. There we go. All right, so what I want to do is I will create an instance of the facade. So we called it the laptop facade. And I'm going to store that in a variable called facade. All right, so now next, after we create an instance of the facade, we can go ahead and make use of this method that belongs to the facade here and say facade dot start laptop. All right, so now at this point, I'm going to go ahead and run this code and let's see what we get. So I'm going to run it and look at what we get here. So we see that power being supplied, the CPU is started, and memory is loading. So all of this here occurred as a result of executing the start laptop, right? Us as a client, we had a simplified way to get a laptop up and running by calling this start laptop. And under the hood or behind the scenes, all these tasks were being delegated to the subsystem components here. So again, remember, like we went to the definition of the facade, right? The facade is like the outside. So in our case, we this start laptop method that we have here is like the outside of this building here. And we, as the client, were unaware, or we did not need to know of what internally was, what tasks were being done internally to get the computer to turn on. All that stuff was hidden away from us. All we cared about was calling a start laptop method, and it dealt with all of those, took care of the rest for us. Okay, so I hope you see the potential for this facade pattern and how this could come to use. Personally, for me, I feel as though this is my favorite one. I could see how I could leverage this pattern in many future projects. So I hope you feel the same way, and I hope I was able to simplify it to you. And thanks for watching, and have happy coding.